Okay, it looks like we're live. So basically, I'm gonna get back to building my own programming language. So here's the code for it. There we go. It's in the chat. Yeah. So I've been working on it actually, off stream. So I got variables just about working. So yeah, this works entirely. So if we run that, order of operations is not implemented still, but yeah, if I run that, and let's see, and then I run 6, and that's the correct answer. And we can also make int hal equals 3, and then we can do, actually let's do 2, then we can do times hal, so that's gonna be 60. So if we run it again, and okay, balls, oh yes, okay, there we go. Yes, that was just a syntax error. 6. Oh shoot, I must have done something wrong. Huh. I swear it was working just a second ago. Let's see. 10. Why would this not work? Alright, so it must not be getting the correct value. Let's look at the assembly. Which I'm going to go into all that I did. But let's see why it's not working. Right, so we push. And then we get, let's see, so that's the first one, which is what we want. And then, yeah, okay. And then we get a second, which would be 3. Yeah, so that should be right, because that should be 10 times 3. And then we push it, and that's going to be where the value is stored. And then pop it. Okay. So here's the problem. We're popping, and then we're popping again into the same register, and then we're multiplying. Okay. Alright. Let me see if I can fix this. So this is gonna be, let's see, handle multiplication. Might be in here. Okay, let's see. It's not gonna be in here actually, because we are doing RAX. Actually, push. Alright, so it's gonna be down here, it looks like. Alright, in this one. Okay, alright, so I think I want this value to be RBX. $60, okay. Alright, there we go. So yeah, that was the problem. It was just put the wrong register value. Alright, let's see. That should work. 15. Okay, let's see. Alright, yeah. So it looks like it's all working now. If you make this plus, it should work as well. So that should be 17, yeah. Okay, so let's go over the changes that I made. Alright, so first of all, I separated some things out into different functions. So like push var, which is for pushing variables, pop, and then move. Let's see. And then I also, I'm setting the stack size. So this is so when we push something in the stack, we can keep track of the stack size. And that's important for knowing where the variables are at. And then we also have a hash map in here. A different one from the other one. It's actually a better implementation. I should probably use this one over the other one for both things, but it's fine. Alright, let's see. So yeah, when we push, we increment the stack size. And then when we pop, we de-increment it. Yeah. So then that way we can keep track of it. So for example, it's a really messy. So I'm gonna need to go through and clean it all up, but not right now. So if we look here, this is where we handle declaring variables. Value, yeah, and then if it's an identifier, and we have to generate operator code. Let's see, but basically we're pushing onto a hash map the value, and this is the variable name, and then also the current stack size. So basically, I can show in here. Here, I'll delete this code. Alright, basically I'm going to show how the variables work. So, if you, say you make some variable, you have x equals 10, y equals 20, z equals 30, for example, right? And then you want to get the value of 10. You can't just pop rax, because that won't work, right? Because that's going to get the top value. So what you have to do, it's RSP, that's the register that it's in. This is basically the current stack. And then you add whichever value you want. So if you want the first value, you would add 0. And if you want that's the top value, you add 0. If you want the value right under that, you would add 8 and then 16. So it's in increments of 8 because of bits. And actually you can only push it. Basically, what this is doing, I can illustrate it. Basically you have the stack here, right? So we put 10 on, and then 20, and then 30. So then we have the stack pointer, which is at the top, right? And so if you want to get this value, then you would add 16. So each 8 you add, it goes down by 1. So you add 8 and it goes down to 20. And then you add 16 and it'll go down to 10. And if you add 0, it just stays where it's at, obviously. I spelled this one. Push. So when you want it, you go to 10, right? That'd be plus 16. And then what that will do is it'll create a new value on the top. And then what you can do here, as you can see, you pop it. So I can build this, and as long as I didn't... Alright, let's see. I messed something up. Okay, RSP plus 16. Alright, operation size not specified. I don't know what that means. Alright, let me actually have it generate the code. Alright, and then we can reload this file. Load file. Okay. Okay, I know what the problem was actually. You need to have the keyword, because that tells it the size. So that we save that. And now if we want to listen, there we go. And then generated. And just like we wanted, we got the value of 10. So basically, yeah, it pushes it there, and then you pop it off, so it's gone from the stack. But then you have the value at the top. So that's basically how the variables work. Yes. Yes, we're keeping track of that. And then it's just a lot of tedious work, basically, like checking if it's int, and then handling it this way, and then checking if it's an identifier and handling it by reading the value of the hash map. Because that's basically, yeah, in the hash map, we have the value. So for example, you have x, and then it points to, in the hash map, its location on the stack pointer. So say it's the third one, right? Yeah. So then you just search the hash map, and there's a lot of error handling and stuff that needs to be done, like you can redeclare variables and stuff. So that changes the whole thing. Yeah, it actually breaks it. No, actually, it might not break it. Alright, yeah, so that works, but how we'd want this to work instead would be that, right? Where you're reassigning it. I'm not gonna worry about that yet. So let me think about what we can do now. So we got all that. I don't really want to clean it up on stream. That's like an off stream kind of thing. Let's see. Well, actually, I can look for all the print f, and then get rid of some of the print f. Okay. Let's see if. Alright, maybe I won't do it. So, let's see. I think what makes sense to come next, besides the handling like multiplication priority, is working with scope, right? So you can create variables in here like scope equals 7, right? And then you can access it in here. But then out here, you can't access it, right? So basically, let's see, that would work if we draw another one of these. And you have your variables here, x and y, or x again, and y. And then you have the certain scope here where they're declared, where it puts z, right? And then you keep track of this, right? You have a pointer to it. Keep track of it, and then once you exit the scope, it just pops it off until it gets to the bottom, the initial value. So I think that'd be fairly easy. So let me save that. Let's go to the Lexer, and let's add. Would that be a separator? Let me see actually. Lexical analysis. Yeah, Wikipedia. Let's see. Would that be what kind of token separator? All right, yeah. I'll put it as a separator. That works. So we don't need to do that. Now we just need to basically handle it. Open curly and close curly. So let's see. All right, I think it makes sense to do it right here. So we do else if current index equals open, token equals generate current index separator, and then tokens index with tokens index plus plus. All right, and then we need to do the same thing for close. Whoops. Let me copy that again. Okay. And yeah, so I'll just change this, and that should work. So now let's test to make sure this works. C, and we'll just comment it out. Okay, I'm gonna build it. All right, and it's all the way up here. So yeah, separator and separator. All right, so that all worked. So now, now we need to parse it. So I'll just move this down here. So let's think about how the tree is gonna look. Let's open up Parser. Let's see. Let's draw a tree. So we have the main program. Then off to the left, we can have like variables and stuff, and then to the right of them, we'll have the semicolon. Right? Let's see. That's a semicolon, not an I. And then to the left of that, we have an open curly bracket. And then to the right of that is obviously going to be the close. And then anything in here is like int and then the close, and like X. Yeah. So that's how it'll work. And then once we encounter the close parentheses, we will end scope, pop all the things off until the stack pointer is the right value. Yeah, that makes sense. All right. So let's go to the parser and let's think about how we do this. So let's see. Let's go down. Messy code in here. Okay. Let's see. Separator. So that's where we're gonna start. Let's see. So if current token value is open, then we're gonna do that, and let's see, and then we'll do down here close. Okay, so I think we can just do basically let's see, let's see, how do we want to go about doing this? If we do current left, make a new node, open curly equals malloc size of node, and then open curly equals init curly. Let's see, what else do we need? Current token value, and then separator. Separator. Okay. Equals open curly. Current equals open curly. Okay. Actually, yeah, I want it to be left. Okay. I gotta spell this right now. Separate. Okay. And let's see, is there something else? Alright, then we're on the current. Then, let's see. And then we'll also, let's see. Trying to think. So then once we get to the close, we want to set alright, well let's try this and let's see what happens. Close curly, close curly, close curly, close curly. Alright, current right. Alright, so let's see. Alright, we have some problem. I probably forgot a semicolon. Yes, indeed. Okay. Another one. Alright, let's see. Should I put something here? Oop, that's a problem. Okay, this should be closed curly. Alright. Oh, this needs to be init node. Alright, and then unused variable test. Alright. Whoops, actually I don't want to do that. Alright, so let's see, I want to look at what it generates. Wait, actually, yeah, I did want to do that. Okay, so let's see, where do we... Alright, let me open up another terminal. And let's run build /main test. Okay. And let's draw this and see how it looks. So basically we have the program. And the left is open. And then we have to the right of that the close. And then let's see, this goes all the way down. All the way down until the exit. Yeah, so I don't think we want that. Let's see, what does our file look like? Oh, hey, but we have an exit in there. Alright, let's run this again. Oh shoot. This should be in, not left. Alright. Left. There's no more. Okay. Okay. So that doesn't work. Okay, let me think. The problem, right? So I can't just, alright, well, let's see. I can't, where is, yeah. I can't just go up here and do something like node open curly equals node size of node. Nasamura 2 based followed. Thank you very much. Sorry if I messed up your name. Okay. Let's see. So we have the open curly here. Yeah. So I can't just do this and then set close curly right equal to that. Because no, I mean open. I can't do that because we could have nested scopes, and that would be a problem. I'm pretty sure that would generate just about the right thing though, because so left. That might be right. Yeah, that's right actually. Mostly right. Let me see. Okay. Yeah, then everything else is a sub of this, but that's okay, because this will be out of the scope, so it doesn't even matter. But the problem is that we can't have nested. We couldn't do something like this. Because now if we run that, then we get the problem that we only have one closing. So, and we also can't just close it here because actually, hang on, let me think. If we do something like token temp equals current token, alright, and then we set up the open curly, and then let's see, we do while temp does not equal, actually temp value, is that gonna work? Temp height does not equal n of tokens. Alright, let's see. If we do that, then we can do current token plus plus. No, we can do temp plus plus. And then let's see. Then we can do if temp equals end of tokens, or temp equals nil. I want to do this. Then we can print error expected that, and then exit. And then we can do if equals separator, and then if string compare, let's see. Value is close parentheses equals 0. Then we can create this. And we don't need this at all. Let's see. Alright, then I think we can, let's see. Alright, we have some problem. Yeah. Temp. Let's see, where else? 377. Okay. Alright, now. Alright. Expected that. Okay, so that didn't work. Let's see. Okay. Okay. Oh shoot. That's a few more than I wanted. That's a problem. So why is there so many open? Actually, we want to break. Oh, alright, well this is a problem. So this needs to be temp value. That can be temp value also. Alright, and then that fixes. Alright, so then we just need to check at the end. Let's see. So right here, if temp type equals end of tokens, error expected that. Exit with 1. Rebuild this. Okay, so now we shouldn't be able to do something like that. That should break it. Okay. Alright, I see what the problem is. So we do... Dang. Alright. So when here, that's working. And then the left of this... Yeah. Alright, so that's alright. Problem is that when we get rid of this one, it still sees it as valid. Because this one checks, and then, oh, there's a close parentheses. And then this one checks, and it's like, oh, there's a close parentheses. So we need to make sure... I think what we can do, actually, if we do something like... let's see. Let's see. Curly count equals 0. And here we do if stochastic value is open parentheses. Then what we have to do is curly count plus plus. And then let me think actually. So if we do that, we have the open. We go through, we see the another open, we do that. Alright, so then what we have to do is if curly count does not equal 0, whoops, then let's see. Then we want to just continue basically. Alright, and we can do curly count minus minus. Let's do that actually. Then, okay, that's looking good. And if we place it back, it should, dang, alright. Let's see. Let's actually, let me change this so I can see which one it is. Alright, so we get to this one. So, let's print f curly count is that, so we can see how it's looking. Curly count is 2 and then 1. Okay. Okay. So I think what we can do actually is temp plus plus. Okay. Alright. Now it should work. Okay. That's looking good. Now if we go here and we get rid of that one. Okay, and then it's expected that. Get rid of that. Expected that. And then if we get rid of this one and we go here and do that. Okay, yeah. So that's looking pretty good. Now we can detect that, because that's pretty important. And I think it should be building the right tree. Okay, not quite. Ooh, okay. Okay. So the problem, we're setting current equal to this, but we don't want to do that until after we go through all the other things. So what happens if we just get rid of that entirely? What does it look like? Let's see. Yeah, okay. So what we are trying to do, we have this, and then to the right of that we have the close parentheses or close curly, and then we want anything that's within them to be to the left of this, right? And then anything outside of it should be to the left of this since it comes first. So we need to set it the current equal to close curly, after we set all of these. I'm gonna try something. Current token value is closed. Then we need to actually do equals 0. Then we'll do current equals closed. Alright, let's see what this does. Okay. Alright, so we just need to see how this works with scope, with the other scope. Alright, but we have this, and all of those are declared within here. Alright, so let's try, we have this in here, then we have something else here, so nested equals 9. Alright, let's see what that does. Okay, let's see. So the left, we have scope again. Then within there, X. Alright, this isn't quite right. Because now it's putting everything within the scope again. Because we lose the value of this. We lose this value once we set this one equal to that. So how can we do this? We need to set the current equal to the current close curly. Not sure how we could do that. Because when we just have this, I'm pretty sure it is working properly. Left and then right, yeah. So that's all how we want it. We just want to be able to do this with nested scopes. Okay. We need to somehow save this value each time. I'm not quite sure how to do that. Alright, well maybe we can get to that later. Let's try to instead let's try to get it working with just the one scope. So this, which we have here, let's try to get something like this. So basically, in code generator, let's see if we token type is. Alright, let's see, where do we want to declare this? Man, this is a mess in here. Let's see. I'll just put it here. No, I'll put it right here. Node value is open. Basically, what we want to do is want to keep track of the current value of the stack. So the current stack value equals stack size. So then that would keep track of it. Actually, let's do current stack value equals malloc. Alright, and then we can, let's see. Then when it's closed though, we want to do basically size ti equals 0 current stack, which that won't be declared in the scope, I believe. Then we can just basically do pop just pop it. Let's see, maybe we could pop it into a different register. We'll use that one for now. I don't know if that'll work, but then we just want to do that until, let's see, until stack size equals that. That's what we want to do. We don't actually need I, so this isn't going to work now because it is not in the scope. So we could make it a global variable, but the problem with doing that is that we can only do it once, so the nested breaks again. But let's try that. Let's do size t current stack value size for consistency. And then if we go here, current stack size, we don't need that. Alright, let's see. So that'll build now. Alright, we're not actually running this, so let me. Alright, let's see what happens. Okay, and let's look at what we have generated. Okay, that's not what I expected. Let's see. Let's see if that runs. Alright, so that does run. And this one as well, I assume. Let's place it in here. But it doesn't run in here. Ooh, okay, actually. So now if we declare again equals 11 equals 12, now it should run 3 times. Yes. Alright, and now 34. Okay. So we shouldn't, if we try to do again, for example, then we get the wrong value because it's no longer in there. But we didn't actually remove it from the hash map. So if we go in here, let me see actually. Let me open something. This is the hash map library I am using. So let's see if there is remove something from a hash map. My fan on my computer is heating up. Alright, basically we want to remove it from the hash map, but we need to know. Ooh, okay, we need to know which one we're removing. Okay, let me think, because we don't really have access to that. We have the current stack size. We could just remove everything, but obviously that wouldn't work. Alright, let's see. So, basically, what we have, we're declaring these variables, then we're popping them off the stack, right? But the problem is that we can't remove them from the hash map because we don't have their names, and that's how they're stored in the hash map. Let's see. We can't just iterate by. Well, we could do that. Yeah, alright, let's try this actually. Let's see. So this is iterating all over the values in the hash map, right? Yeah, okay. So let's look at it. Yeah, hash map, iterate. What is iterate? Not sure. Value. Okay. Error. Okay, let's see. Okay, let's see. So we need to declare int value. So now we're iterating through, and we want to check if the value is equal to if. Alright, let me actually grab this. Let's do this. Okay, we can remove this. Okay. It's greater than current stack size. So how do we get that? Alright, have some problems. Alright, I know what the problem is. This is not how we put hash map. Okay. Let's see. Alright, yeah, so iterate is undeclared. So where does it... Ooh, okay. So that's the function there. This is not right, actually. That is not what I wanted to do, actually. Oops. Let's make it size key. Zoo. Alright, let's see. Okay. So that does not work. Okay. Okay. Let me actually, let's open the hashmap.h and let's look at hashmap iterate. In iterate. Whoops, didn't mean to do that. Let's see. Okay, let's see. Alright, let's let's move this out of this function. And let's type int iterate. Alright, then we can set this up so we don't need this. And then we want to call iterate from in here. Iterate. And what do we want to pass? So, context. Let's try 0, and then value is 0. No. There we go. Highlighting, it's all weird. Alright, let's see what happens when we pass that. And let's go up here. Void context, void value. Okay, then if 42 equals int value void context equals value. Then return 0. Return 1. Oh, then that's the end of the function. Okay, and then this stuff can actually go back where we had it. Back down here. Right in here. Okay. Actually, yeah. And then, let's see. Let's see if this gets called. Okay. So that gets called. So we want this. Then let's see, we can Okay. So we found that. So basically, we want to just remove this from the hash map. Let's see what this print does. That doesn't. Let's see. We'll print out that. Okay. Go back in here. No. Right. Hash map. Right. So it doesn't return the value then. It looks like. Just returns 1 or 0 if it's in there. So let's think about another way to do this. Let's go in here. So let's just get rid of this code. And we'll get rid of this. Alright, let's see. So so like we could create another hash map and then destroy. No, I don't think. Yeah, okay. Man, we're really close to it working. Really close. Because once we get this working, you know, we could have if statements, like, and then we have the declared scope. So like if I is less than 3, you know, and then yeah. But the problem is that we don't have it working. Yeah, but that's basically what's next. Once we get the scopes working, I'll probably refine the variables a bit, like fix a couple bugs with it and such, off stream. Yeah, but this is gonna have to be the end for today. I will working on scope mostly implemented. Just need to remove from hash map and add nested scopes. Okay, there we go. So that should be up on the GitHub now. Alright, there we go. Yep. Yeah. So we're getting there. You know, we're getting. So I'll work. Well, I probably won't work on it too much. I'll think about how we can get all this working, and then next stream, we'll get it working. Maybe refine the variables of it, and then we can add if statements and while loops, and then we're pretty close actually to being able to do fizz buzz. Then basically we just need a way to write, because then you could basically make fizz buzz with something like while I is less than 100, you know, we can check if, so we need to also implement modulus, but yeah, we could do something like if 3, you know, right, fizz buzz, you know how it goes. Yeah, so we're not too far away. I mean, even though the while loops and if statements are really the most complicated parts, but yeah. So that's next time.